Rather than, I love the word guesstimate. I love that phrase. I'm going to make it a little more concrete, actually, if it's okay with you. So, an interpolation, or to interpolate. We'll make it a verb. To interpolate. What that means is to make a mathematical prediction within a set of data you already have. Okay? To make a mathematical prediction. I apologize for the marker, it's starting to fade a little bit. To make a mathematical prediction within known data. So we did quite a bit of that today. What happened? I know, I apologize for the cover. Turn the light on. A little bit quicker, you see a hope. Maybe-ish. Tiny bit. So what you've done is, when I asked you how many uninsured were there in 1995, 1995 was within that data set. That was an interpolation. When I asked you when were there 40 million uninsured, 40 million is within that data set. That was an interpolation. We felt pretty good about that, didn't we? Did anybody say like, oh my God, that 40 million, that should have been like 32 million? Was anybody feeling that way at that point? Tell me if you were. It's okay if you were. I just don't think there's any reason to feel that way, because within that tight data set that we had, I mean, there's a little bit of a hiccup here, but it's fairly flat within that data set. So we're not going to be off by 14 million like we were at the end. We might be off by 500,000 or so, but that's understandable. That goes back to Brittany, Amy, and Ashley's and my rounding deal, which we're going to be dealing with by the end of the day today. That's interpolation. The trick, though, is extrapolation. That's a much better color. We'll use that. To extrapolate, verb. Now, I love the word guesstimate, but I'm going to compare and contrast it with interpolate. All this means is to make a mathematical prediction where? Where?
In the data.
Not in the data, outside of the data that we have. That was the problem with 2014. It was nowhere near our data set. Our data set stopped at 2000. And then I was making you predict 14 years later. What happened 14 years later? You were well outside of that data set then. So, to make a mathematical prediction outside a known data set. Brittany, or Ashley, tell me what's on your mind. You got a thought coming. Let me hear it.
Oh no, I just didn't understand. How do you know when it... Which way?
How do you know outside versus inside?
Yeah.
So here's the data. I'm going to back up the slide for a second here. Every bit of math we did today was based on those 5 data points. Every bit of math that we've been doing was based on those 5 data points right there.
So a trend wouldn't be within those data points?
That would be interpolated. Anything within these data points. If we wanted to do 1995, 1993, 1997, 1999, for example. That's within those 5 data points. That's all interpolated. We feel pretty good about that.
Yeah. No.
When I asked you about 2014, now we're over here. Nowhere near that data. What can happen once this data runs out? I mean, it's possible that it continues that trend. It's possible that that trend continues. We keep picking up 1 million people per year uninsured. It's possible. Did that happen in reality? No. It looks like that didn't happen in reality. We scroll forward again. It looks like what happened was we're beginning to see not a leveling off, but a dropping. It's starting to go kind of like this, which we'll get to what that means by Wednesday of this week. What happens when the data doesn't go in a straight line? It doesn't appear to trend in a straight line. We adjust. So does that make sense, Ash? Great point. You've got to watch extrapolation. That's what got America into the housing crisis. Holy crap! I bought a house in 1992. It doubled in value in 94. It doubled in value in 98. It doubled in value. It's going to keep doing that forever. Boom. Or it won't. Right? And that's what got us into the trouble. Or it won't. And then, all of a sudden, the pattern was going like this. And the graph changed. And the graph changed. And then we hurt because we were banking on the graph not changing, but then it did change, and then everything sucks. Fair? The idea, though, is when to extrapolate and how you should feel about extrapolation. Would you feel better about extrapolating closer or farther away from your data set?
Closer.
That makes perfect sense, doesn't it? Because chances are the big changes aren't going to happen in one moment. Sometimes they do. Sometimes they do. Obama's approval rating and George W. Bush's approval rating are amazingly explosive right after a large foreign conflict is declared. Now, after 9/11, George W. Bush's approval rating through the roof. Because, for whatever reason, socioeconomically, that ties to a large approval rating jump. But that's the rare occasion. It doesn't usually do that. It's usually a slow change over time. Fair enough? Okay. Ask me questions if you have them right now. This is a lot of statistics to hit you with at 9:30 in the morning. I apologize for that. Kind of. I don't really apologize. It's actually a good thing. Good? All right. So what I want to do now is change the data set. Let's change it. Let's use something a little closer to home. Mount Bachelor ticket prices.